The last example demonstrates that converting from Cartesian coordinates or rectangular coordinates to polar coordinates when the point lies on one of the coordinate axes is relatively easy. This next example demonstrates what we're going to do if the rectangular coordinates lie in one of the quadrants. For example, we have the point A is 2, -2. We want to take this point and convert it into polar coordinates. The first step in doing this should always be to plot the point to help us visualize the solution. So the point 2, -2 is in the fourth quadrant. So here's what our goal is. Our goal is to find the value of r, the distance from the pole to the point. And in addition to that, we need to find the angle theta. We have a lot of different choices here, you'll recall, but probably the easiest thing to do is to select the angle theta that's going to go in the clockwise direction so that theta will be negative. So, to find the value of r, that's just the distance from the origin to the point. So clearly that can be found by taking x squared plus y squared and computing the square root. So we're going to be taking the square root of 4 plus 4. The square root of 8 is 2√2. So the value of r is 2√2. Now we need to find theta. Well, what we should notice here is that I have the x-coordinate and the y-coordinate. Recall that the tangent of an angle theta is given by the y-coordinate over the x-coordinate. Therefore, theta can be found by computing the inverse tangent of y over x. Remember, the angle theta is going to be between -π/2 and π/2, because you should recall that that was the restricted domain on the tangent function in order to make it 1-to-1. So in this particular problem we'll be okay because we're clearly going to get an angle that's between -π/2 and 0 because I'm in the fourth quadrant. So in this particular example, we're going to get that theta equals the inverse tangent of -2/2, which is the inverse tangent of -1. And we ask ourselves, what angle has as its tangent -1? And you should remember that that angle is going to be -π/4. Therefore, in polar coordinates, the point 2, -2 can be represented as 2√2, -π/4. There are many other representations of this point as well. For example, if I went in the counterclockwise direction, I could write this as 2√2, 7π/4 by adding 2π. I could also have the value of r be negative, so -2√2, in which case my angle would have to be over here in the second quadrant, but that's not so hard to do. Just add pi to this angle, so pi plus -π/4 is 3π/4. So I have three representations of the same point. Let's do another example where in this next example we're going to take the point -1, -√3 and convert it to polar coordinates. So again, the first thing that you always want to do is plot the points in the Cartesian plane. So x is -1 and y is -√3, which is about -1.7-ish or so. So there's our point, -1, -√3. So we have many choices for our angle theta. Suppose that we're going to find our angle theta to be the positive angle whose terminal side is going to be in the third quadrant. So we know theta is going to be between pi and 3π/2. First, we'll find the value of r. Remember, r is the distance from the pole to the point. So r is the square root of negative 1 squared plus negative root 3 squared. So that gives us the square root of 1 plus 3, which is the square root of 4. Square root of 4 is 2. So r is 2. Now what we need to do is find theta. Well, remember that the value of theta is the inverse tangent of y over x. But again, this is going to give us an angle between negative pi over 2 and pi over 2. Between negative pi over 2 and pi over 2 would put a terminal side in either quadrant 4 or 1. We need our angle to be in quadrant 3. So we're going to have to make some adjustments to our result. Let's first compute the value of theta that we're going to get by using the inverse tangent. So we're going to have the inverse tangent of negative root 3 over negative 1. So that's the inverse tangent of the square root of 3. So we need to ask ourselves what angle theta has as its tangent, square root of 3. The angle that we're going to get is pi over 3. So pi over 3, of course, is in the first quadrant. How can I get the angle into the third quadrant? That would be accomplished by adding pi to this angle. So my angle theta is going to be pi over 3 plus pi, or 4 pi over 3. Notice how the graph is helping us to get these results. That's why drawing it is so important. So in polar coordinates, my point could be 2, 4 pi over 3. Another way I could do this is negative 2, say pi over 3. Or 2, maybe add 2 pi to this guy. 2 pi is 6 pi over 3, so I could have 10 pi over 3. Or I could even subtract 2 pi. So minus 2 pi would be a negative 2 pi over 3. So we now have 4 representations of the same point in the Cartesian plane.